Hello everyone, today we are going to talk about nanomaterials and their classifications. My name is Kanitman, roll number 19 BCE 2040. Before we get into the classifications, we first need to understand what nanotechnology and nanomaterial is. Well, to get an idea, let me go with the definition. Nano is derived from Greek word which means dwarf, and in scientific notation it is 10 to the power minus 9 meter. Now that is really small. According to the definition, nanotechnology deals with the very smallest component of our world, atoms and molecules. Well, we can also call it a billionth of a meter. But before we can understand what and how small nanomaterials are, we first need to see how small a nano is. I have noted down some comparisons so that we can get a feel of what we are going to study next. Now here are some very basic comparisons. A human hair is about 60,000 or 100,000 times nanometer. That is, it is 60,000 times wider than a nanometer. I think we are getting some clue over here. But let's see one more example. A fingernail grows at 1 nanometer per second rate. We know that fingernails grow very small, very slowly, but 1 nanometer per second. It is hard to visualize, but we are getting the feel, right? Now with this last example, I think everything will be clear with us. Width of a sheet of paper is 10 to the power 6 times a nanometer. Now that is really thin. Now that we have known how small a nanomaterial is, let us see the different types of nanomaterials. Well, conventionally we have a low dimension system which consists of 3 types of nanomaterials, that is quantum dot, quantum wire and quantum well. That is 0 degree, 0 dimension, 1 dimension and 2 dimensions respectively. Let's see what quantum dot is. Now what a quantum dot is. Now the basic definition of a quantum dot suggests that it is a nanoparticle or nanocrystal which has force being applied from all 6 directions that confine it to 0 dimension. Small nanoparticles are often called quantum dots, and its dimension is from 1 to 50 nanometer in size. We have example as hydrogen atom or helium nucleus. The second type is quantum wire. Quantum wire where electrons are free to move in only one direction and are confined in 2 directions. Let us suppose the diagram given over here. We see that the y-axis and z-axis are confined, but electrons are free to move in x-axis. That is, the electrons can move only in one direction. The example are carbon nanotubes. Now let us come to the final part, that is quantum well. We have already started to see the similarity, don't we? We have seen 0 dimension and first dimension quantum confinement. Now this is 2 dimension quantum confinement. That is, the electrons can move in 2 directions and only one direction is confined. We can see from the example of the sheet given here. It is confined in only x-axis, z-axis, and it is free to move in x and y-axis. This is the example of quantum well. The definition states that area but the thickness are only a few nanometers. Nanosheets and nanowall belong to this category. And we have a very common example, that is graphite. And that is the revision page we are seeing. That we have seen that quantum dot is restricted in all 3 axes and is called 0 dimensional, whereas quantum wire has only one axis free and other 2 axes are restricted for electron movement. and thus is called one-dimensional. Quantum well has two axes free for electron transfer and electron movement, whereas it is restricted at axis 3 and is called two-dimensional. Thank you. That was all from my part.